Hello, in this video I'm going to solve a problem for you on the topic of trigonometric equations. Let us read the problem together first. Solve the following equation. Sine of x minus 22.5 degrees squared plus 2 times cosine of 112.5 degrees minus x equals to 3. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, what you will get at the end is x equals to 112.5 degrees plus n times 360 degrees, where n is an integer. Okay, now I have written the problem here on the board. So you know that if you want to solve a trigonometric equation, in general, you have to be able to reduce that equation into one or multiple of standard forms of trigonometric equations, which are equality of sine equals to a number, cosine equals to a number, and tangent equals to a number. These are trigonometric equations that are standard for us and we know how to solve them. Okay, but unfortunately here we have a mixture of sine and cosine. So if you have a little bit harder problem, this is the nature of those problems. You need to be able to understand the connection between sine and cosine or other parts of the equation, so that helps you to reduce that given equation into one or possibly more standard equations. Okay, one thing that is actually the point of this question is to discover this relation between the angle in front of sine and the angle in front of cosine. So I have deliberately written 22.5 degrees and 112.5 degrees to distract you a little bit. But by practice, you learn how to be more observant. So if I ask you what is the connection of the angle between in front of sine and cosine, immediately you should be able to see that, because if you see, you might ask yourself, okay, I don't know the value of x, how can I find the connection between two unknown angles? You are somehow right, but if you look closer, you see that if I add these two angles, regardless of the value of x, the sum is always 90 degrees. Let us check. X minus 22.5 degrees, which is the angle in front of sine, plus 112.5 degrees minus x, which is the angle in front of cosine. If I add them, then you see that the value of x doesn't play any roles here, because whatever that x is, that is the same, they are cancelled. And then what happens, these two numbers, minus 22.5 degrees plus 112.5 degrees, it becomes exactly 90 degrees. Okay, so that was the point of this problem. So you realize that these two angles, regardless of the value of the unknown x, are always complementary. And if you have already studied your lessons in a proper way, so this is important to realize, if two angles are complementary, there is a very nice relation between sine and cosine of such a pair of angles. And that is sine of one of them is equal to the cosine of the other one, and vice versa. So this means that if I can see this point, then I can get rid of one of them in favor of the other one. So instead of having an equation containing a mixture of sine and cosine, then I will have an equation either in terms of sine only or in terms of cosine only, which is actually simpler to solve. So what I do here, I probably eliminate cosine in favor of sine. It doesn't matter if you do it the other way around. So I would say that cosine 112.5 degrees minus x is equal to the sine of its complement, but we realize this is its complement. So this means that if I want to rewrite the equation, I copy and paste the first part that I want to keep, plus 2 times. Instead of this, I write again sine of x minus 22.5 degrees, and on the right hand side I have 3. And hopefully you remember the trick of auxiliary variable, yes? So you see that this combination, sine of this angle, appears here and there in one single equation. This might motivate us to give this a new name. Okay, so I would say let capital X be equal to sine of x minus 22.5 degrees. Okay, then what happens? Instead of this, I can write capital X, then I have power of 2 plus 2. Instead of that, I can write capital X, and this is equal to 3. I hope that you agree with me that solving this equation is extremely simple, because this is probably one of the simplest quadratic equations ever. Okay, how can I solve that? Either you can use PQ formula or ABC formula. I prefer to use ABC formula, so I move this to the left, and then I use ABC formula to solve the problem. So it becomes minus 2 plus or minus the square root of this number to power 2 minus 4 times this number times that number. Minus minus become positive, and then divided by 2 times a, which is 2. But of course, 4 plus 12 is 16, the square root of 16 is 4. So this means that x is equal to minus 2 plus or minus 4 divided by 2. Then I will have two possibilities. If I consider the negative sign, minus 2 minus 4 is minus 6 divided by 2 is minus 3, or x is equal to minus 2 plus 4 is 2, 2 divided by 2 is 1. So I need to solve, because my goal was to find the little x. So far I found the capital X. So I have to replace the capital X. I have to replace this capital X with those values and then solve the problem in each case to find the little x. But hopefully you realize the first one is not acceptable, because if x is minus 3, this means that sine of x minus 22.5 degrees is supposed to be minus 3. So no solutions. Why is that? Because you know that sine of an angle is maximally 1 and minimally minus 1. Yes? So you see that this cannot happen, because this number minus 3 is below minus 1. But the other scenario is that x equals to 1. So this means that sine of x minus 22.5 degrees is equal to 1. But where sine is equal to 1, either you use the formulas that you had in the lesson, or you can just visualize it on the unit circle. You know that sine is the y-coordinate, and you want to have the y-coordinate of a point of the unit circle to be 1. There is exactly one point with that property, and that is this point, which corresponds to 90 degrees. So x minus 22.5 degrees is equal to 90 degrees, but of course 90 degrees one of those answers, because if you go one full round in any direction, you will get back to the same point, so it means the sine value is the same. So this means that you are able to add any multiple, any integer multiple of 360 degrees. Yes, so n of course is an integer. Okay, but I'm looking for x, so I move this to the other side. This becomes positive 22.5 degrees. There is a 90 degrees here. If I add it, it becomes 112.5 degrees plus n times 360 degrees, where n belongs to z. And that is the answer provided by the problem for you in the beginning. Okay, I hope that you enjoyed the problem. Until the next video, be safe and goodbye. Thank you.